What if we could measure in real time how cancer therapies destroy tumor cells and prove they work right where it matters? That's the challenge when it comes to DNA damage response inhibitors, therapies that push cancer cells beyond their ability to repair DNA, leading to cell death. But to bring these innovative drugs from concept to clinic, we need one thing: the right biomarkers. The journey to new cancer treatments is long, complex, and expensive. And with DDR inhibitors, one of the biggest hurdles is this: how can we accurately measure DNA damage to understand the efficacy and the mechanisms of action of these drugs? We need biomarkers that are specific, sensitive, reproducible, markers that instantly report the drug's effect and provide clear, measurable signals. These biomarkers must work both in preclinical studies and later in patients during clinical trials. That's often much harder than it sounds. If we want therapies that damage cancer cells without harming healthy ones, we need precision technologies for direct in situ detection and quantification of DNA damage in cells. If you'd like to explore how this works in practice, let's connect. Also, check out our previous film about DDR inhibitors.